Hello, my dear students. I hope you are fine. This concept is talking about the effect of gravity. As we see in this picture, the ball is moving down to the ground. Have you ever asked yourself why objects keep falling on the ground and not flying upward? This happens as the Earth has a pulling force called gravity. Gravity is the force that keeps all objects on Earth's surface. Gravity is the force pulls object with mass toward the center of Earth. So we can conclude that the direction of gravity is toward the center of Earth. On Earth, gravity pulls everything. Everything such as humans, rocks, water bodies, animals, chairs, and hold them to the ground toward the center of Earth. Skydivers and their parachutes are pulled downward to Earth's surface. So they can't keep flying all the time. Sometimes when they want to land, they open their parachute to fall down due to the effect of gravity. As we see, the scientist who study the space is called astronaut. Astronauts float off into space as there is no gravity. So the force of gravity keeps us from floating into space like that happens with astronauts. On Earth, what goes up must come down. Like the pupils that are falling down and not moving upward as the effect of gravity is toward, or the direction of gravity is toward the center of Earth. So gravity changes the direction of anything you throw into the air. When you throw the ball up, it will change its direction toward the ground. When I ask you, give reason, objects like balls drop to the ground after being thrown up into the air, as we know that gravity pulls objects downward toward the center of the earth. Gravity doesn't only act on falling or moving objects, but it also acts on objects that doesn't move, as the chair, or the boy sits on a chair, or a book on a table, or a book on a shelf. The boy is moving down the slide as there is a force called the gravity that pulls the boy so he moves down the slide. What will happen if there were no gravity? The boy won't be held to the slide. We can find the effect of gravity between objects that don't touch each other as the force of gravity between the Earth and the Moon. The force of gravity is pulling the Moon, so the Moon still revolves in its orbit around Earth. What will happen if there is no gravity between Moon and Earth? The Moon would float into space. The force of gravity keeps us from floating into space like that happens with astronauts. Gravity is affected by mass, gravitational force, or the force of gravity of an object increase as the mass increase. When the mass decrease, this means that the gravity also decrease. Gravity is also affected by distance. So when the distance between the object and Earth increase, this means that the force of gravity, the force of pulling object downward, will decrease. As we go far away from Earth, the force of Earth cannot pull the object like the object on the Earth's surface. So gravitational force of an object decreases when the distance between two objects increases. And when the distance increases, this means that the gravity decreases. What happens if the mass of the moon becomes twice? The moon would have more gravity, as we said before, that when the mass increases, the gravitational force increases. So the moon would have more mass, so it would pull closer to Earth and it might even crash into Earth. The distance between the moon and Earth becomes twice. This means that the distance increases, so the gravitational force decreases. The gravitational force between them would be closer. We can conclude that all objects have gravity because all they have mass. Objects with greater mass exert greater force on objects around them, as in the Earth and the Moon system. Where Earth is bigger than the Moon, the Earth has higher mass than the Moon, so it has more mass, so the Earth has a stronger gravity than the Moon. Gravity of the Moon causes attraction of Earth toward the Moon. All objects or near Earth's surface are pulled down toward the center of Earth. The Sun has a biggest mass in the solar system, so it has a biggest gravitational force. The great gravitational force pulling the Sun keeps planets revolving in their orbits. What keeps planets revolving around the Sun? Gravity. As we said, that gravity is the invisible attraction or pulling force that holds all planets in their orbits. The Sun pulls all planets toward it. Gravity keeps our planet in an orbit around the Sun. The Sun is the only center of motion in the solar system as it has the highest mass. So, the Sun is much bigger than the other object in the solar system, so its gravity pulls the other planet toward it. If there were no gravity, the planet would fly off into space. In space, there are big and small planets, where bigger planets have more gravity than other smaller planets. Like the gravity of planets in space, we can say that on Earth's surface, objects with large masses have more gravity than the object with small mass. In 1543, a scientist called Nicholas Copernicus states that Earth revolves around the Sun. In the solar system, each planet revolves around the Sun in a fixed path called an orbit. The orbit of each planet has an oval shape. Earth revolves around the Sun at a speed nearly equals 107,000 km per hour. What keeps the planets revolve around the Sun? Gravity is the invisible attraction or pulling force that holds all the planet in their plans. If there were no gravity, the planets would fly off into space. This force is called pushing force as it makes the car moves away. But this force is called pulling force as it keeps the car near to you. So force is a pull or push that's applied to an object. When the object moves, it changes its position or it changes its location. So motion means a change in the position of an object compared to another object. We have two types of force, contact force and non-contact force. Contact force means the two objects touch each other, but non-contact force means they don't touch each other. So in contact force, the two objects need to contact or need to touch each other as kicking the pole to make it move. But in non-contact force, the two objects don't touch each other as the magnet doesn't need to touch the paper clamp. The metallic bar in the middle acts as a magnet, so it attracts or it pulls the object toward it. So this is called attraction. But here, the two magnets are moving away from each other, and this is called repulsion. So attraction or repulsion is the force of the magnet. So the force of the magnet is called magnetism. Magnetism is the force of attraction or repulsion between two magnets or between a magnet and an object. The magnet attracts metals made of iron or metal objects made of iron, nickel or cobalt. So we can call iron, nickel and cobalt magnetic materials. So magnetism is a force of attraction or repulsion, or the force of pulling or pushing force, but gravity is a pulling force only. So gravity can exert only a pulling force. There are types of forces. The first one is called magnetism. Magnetism means attraction or repulsion. We can see the two magnets are moving away from each other. So this is a pushing force. It causes a magnet to push away another magnet. We can see the effect as the other magnet is pushed away. But here, this is a pulling force of a magnet. It causes a magnet pulls paper clips, and we can see the effect as paper clips move to the magnet. This is wind turbine. It's operated by wind. So wind pushes on the blades of wind turbine, and we can see the effect as wind turbine blades move. When you squeeze a spring, we can see the effect as the spring pushes back when you leave it free. As we studied before, gravity is a type of forces. Gravity pulls a cup you drop to the half, so the cup falls to the ground. When we wrap our hands, we feel warm, as this force is called friction. Friction happens when two objects touch each other. So friction is a force generated between two touching surfaces. Friction slows the movement of object, as when we press on the brakes of the bike, the speed of the bike decreases till it stops. As the wheel of the bike makes a friction with the ground, so friction that opposes the motion of a body across a solid surface or through gas or liquid. The bicycle brake pulls back the movement of tires by friction when a bicycle brake rubs against the tires. This is another type force of friction force, which is called air resistance. The air resistance is a friction force that opposes the movement of an object as it passes through air. So the friction in air is called air resistance. Skydivers land safely as they open their parachute to slow down the landing, as there is a force called air resistance, which is a type of friction force that slows down the motion. Air resistance is a factor that can slow down the falling object. Skydivers release parachute to slow his drop. Where the skydiver opens his parachute, it gets filled with air due to the upward flow of wind forming air resistance to the parachute. The air resistance pulls the skydiver backward and slows his fall to the Earth's surface. This is an activity to know more about the law of motion. If I have two poles, the first one is a metal pole and the second one is a plastic pole with holes. Which one will fall faster? The metal pole will reach the floor faster. If I have a paper clip and a feather, which one will fall faster? The paper clip will reach the floor faster. This means the plastic pole with holes took longer time to reach the floor because it was slowed by upward flowing air more than the metal pole. But here, the feather took longer time to reach the floor due to its shape, as the feather is affected by air resistance more than the paper clip. So that air resistance is a factor that can slow down the falling object. From this activity, we can conclude the law of motion. The force of gravity is constant and acts on all objects in the same way. Let's imagine if there is no air resistance, what will happen? According to the law of motion, if we drop a hammer and a paper at the same time from the same height, they will reach the floor at the same moment because gravity acts on all objects in the same way, where the mass or the shape of the object wouldn't matter.